Hello guys. So we are continuing with our crash course and today's lecture is very important. This permutations and combinations. As you know, from 2019 onwards, we are seeing every year 8 to 10 questions from this single chapter. So it is that important. We'll do it in a little bit more detail, and this lecture may be a bit longer than our previous lectures, but it will be worth it because even if you could solve, let us say, 5 questions out of 10, then also you have sufficient edge to qualify for in the CSAT paper. So let us see the uh, sections. We will go sections by sections and just uh, types of questions that can be asked and few PYQs that were asked in recent times. We will solve those, and if you want solutions of rest of the PYQs, there is already upload. They are already uploaded on LevelUp IAS YouTube channel in our PYQ series. Last 5 years PYQs, solved PYQs have been uploaded. So here today we will not go into that much detail. We will not solve each and every PYQ, but some representative PYQs I'll solve. Fine. So this topic, permutations and combinations, is basically about counting and counting methodically. That is what permutations and combinations is all about. So if you know how to count, if you are fair in counting, even manual counting, you will be able to do half the questions of this topic very easily, and other half, which are standard questions that we are covering here today. Half the questions UPSC is asking, which require you to count manually. Answer is usually in single digits or lower double digit. So you have to count manually there, 1, 2, 3, 4, like that, enlist all the cases and solve. And half the questions, they are standard questions where answer can be bigger. So that is what we'll try to cover today. Typically questions are in the form, in how many ways can we do it, which is to count just numbers, count number of ways. So let us begin at very basics. And if we have these shapes, there are three circles, 2 quadrilaterals or squares, and they are differently colored, so they are different. In how many ways can we pick one shape out of these 5? In how many ways can we pick one shape out of these 5? 5 shapes are there, so there are 5 ways. We can pick this shape, this shape, this shape, this shape, or this shape, right? We can either pick a square or we can pick a circle, correct? We can pick a circle or we can pick a square. Whenever we have this word or, it means addition. That is our addition principle of counting. We'll go into detail. And now, if I want to pick 2 shapes, one circle and one square, then how many ways are there to do it? I can pick circle, this 1 and square 1, or I can pick circle 1, square 2. I can pick circle 2, square 1, or circle 2, square 2. I can pick circle 3, square 1, or circle 3, square 2. So there are 6 ways. 6 ways. If I want to pick a circle and a square, then there are 3 into 2 ways, because there are 3 circles and 2 squares. 3 into 2 ways to do this. This is our multiplication principle of counting. That is the introduction. Let us see those principles in a bit detail, because on multiplication principle at least many questions get asked. And these are fundamental principles of counting: addition principle and multiplication principle. These 2 principles form the basis of entire chapter. So whatever terminologies that we may introduce in the future, like NC3 or NCR or NPR, like N choose R or N permute R, so those are basically derived from these 2 principles and using them repetitively. So these are the foundation of this chapter. So first is addition principle. Let us read. The principle of addition states that if one task can be done in m ways and another task, which is mutually exclusive, can be done in n ways, then number of possible ways in which either can be done is m plus n. मतलब क्या है कि there are 2 tasks. First task, one task can be done in m ways. सेकंड टास्क कैन बी डन इन n ways। और ये दोनों टास्क कैसे हैं? दे आर म्यूचुअली एक्सक्लूसिव। इसका मतलब डूइंग टास्क 1 और टास्क 2 वी कैन नॉट डू बोथ एट द सेम टाइम। मतलब या तो आप टास्क 1 करोगे या फिर टास्क 2 करोगे, दोनों एक साथ नहीं करोगे। वी हैव टू डू वन ऑफ द टू टास्क, दोनों नहीं करना है। दैट इज व्हाट म्यूचुअली एक्सक्लूसिव मीन। ये करोगे तो ये नहीं करोगे, ये करोगे तो ये नहीं करोगे। दैट इज व्हाट म्यूचुअली एक्सक्लूसिव मीन्स। सो दीज टू टास्क्स आर म्यूचुअली एक्सक्लूसिव एंड देन नंबर ऑफ वेज ऑफ डूइंग ईदर वन ऑफ देम इज m प्लस n। जैसे कि हमने स्क्वायर और सर्कल का एग्जांपल लिया था, वहां पे टास्क 1 क्या था? चूजिंग अ सर्कल। टास्क 2 चूजिंग अ स्क्वायर। एंड व्हाट डू यू वांट टू फाइंड आउट अबाउट कि नंबर ऑफ वेज यू कैन चूज वन शेप। तो या तो सर्कल चूज करोगे या फिर स्क्वायर करोगे, दोनों में से दोनों तो एक साथ नहीं कर सकते ना। सो दीज टू टास्क आर म्यूचुअली एक्सक्लूसिव। सो नंबर ऑफ वेज इज 3 plus 2 5। दैट वाज द again another example. If I have 4 apples and 3 oranges in a basket, then there are 3 plus 4 ways of picking up a fruit from the basket. If I want to pick a single fruit, so I have 7 ways of picking a fruit. Here event is picking a fruit. I can pick either apple out of 4 or I can pick an orange out of 3. Picking up an orange or apple is totally unrelated and mutually exclusive to each other. So basically or is addition। जहां पे भी और दिखेगा, जहां पे हम बोलते वक्त और बोलेंगे, वहां पे एडिशन होगा, नंबर ऑफ वेज का एडिशन होगा। दैट इज व्हाट और मींस। ठीक है, ये एडिशन प्रिंसिपल ये बोलता है कि दो इवेंट है, म्यूचुअली एक्सक्लूसिव है, तो दोनों में से एक ही करना है। तो कितने वेज है? m प्लस n वेज। या फिर या तो ये करूं या फिर ये करूं। आई कैन डू टास्क 1 और टास्क 2। और का मतलब होता है एडिशन। दैट इज एडिशन प्रिंसिपल। Second is, this is now multiplication principle. Now what this says is, the principle of multiplication states that if one task can be done in m ways and another task which is independent from the first task can be done in n ways, after the first task has been performed, then number of possible ways in which both tasks can be done is m into n. अब यहाँ पे क्या करना है? We want to do both the tasks. There are two tasks again. There is task 1, task 2. Task 2. You want to do both the tasks, and once task 1 is performed, then task 2 is independent of that performance। मतलब task 1 में जो चाहे choices हो, उससे task 2 की choices पे फर्क नहीं पड़ता है। The task 2 and task 1 are independent of each other. Task 2 is not dependent on task 1। मतलब task 1 में क्या choice होता है, उस पे task 2 का choice कोई dependent नहीं है। That is what we mean। जैसे कि हमारा जो ऊपर का एग्जाम्पल था, सर्कल एंड स्क्वायर। So we wanted to choose two shapes, one circle and one square. So we want to do both the task 1 and task 2. So and task 2 जो है, choosing a square, does it matter which circle I choose? उस पे कुछ डिपेंड करता है क्या स्क्वायर का चॉइस? नहीं। सर्कल आप कोई भी चूज कर लो, यू चूज एनी सर्कल, द चॉइस ऑफ स्क्वायर इज स्टिल, यू कैन चूज एनी वन ऑफ द टू स्क्वायर्स, देयर आर स्टिल टू स्क्वायर्स लेफ्ट। So choice of squares is independent of choice of circles. So these two tasks are independent. Multiplication principle comes into action, and number of possible ways of choosing both shape 1 and shape 2 or circle and a square is 3 into 2, so 6. We want to choose circle and we want to choose square and मतलब multiplication. That is your multiplication principle. But यहाँ पे important है this word, these two tasks has to be independent. If they are dependent, we have to modify our multiplication principle, those, and we cannot use it directly. हाँ देखो, वही लिखा है मैंने, picking one apple and one orange are independent of each other. So no matter which apple I pick, I still have same 3 oranges to pick from. Also in circle and square example, no matter how we pick circle from 3 choices, we still have 2 squares to pick from. In how many ways can you pick one apple and one orange? From 4 apples and 3 oranges in a basket, 4 into 3. So this is 12. Basically, and is multiplication. Whenever I have to do task 1 and task 2, so I multiply things. Whenever I have to do only one task 1 or task 2, I add the things. That is addition principle, multiplication principle. I hope this is clear. Watch it again if this is not clear, because this will form basis for our future chapter, our entire chapter. We will use it again and again. Now let us see what happens if the events are not independent. Event independent नहीं है तो क्या होता है देखते हैं. Let us see this example. Kritika wants to buy a car. Fine. The dealer says she can buy either car A or B. So there are two cars. Fine. Then there are three models of each car, that is GXI, SXI and ZXI. And there are 5 colors for each car. So how many options does she have in total? So dekho, what does the question say? We have two cars A and B. Then we have 3 models, right? Jo bhi hai. And then we have colors. There are 3 models and there are 5 colors in each model. हमें क्या क्या? If you are Kritika, what do I have to do? I have to first choose a car. कार कौन सी लेनी है, A or B? Then we have to choose model and we have to choose color. I have to choose car and model of car and color of car. तीनों भी choose करना है. ऐसा तो है नहीं कि one of them only I have to choose. I have to choose all. I have to choose car as well. I have to choose model as well and I have to choose color as well. So how many ways are there? 2 ways to choose a car in 2, because and is multiplication. I have to choose model and I have to choose color. Total 30 ways are there. Correct. One more way, you can directly enlist. So you can say that she can choose car A or car B. If car A, you have 3 choices: GXI, SXI, ZXI, and B is also GXI, SXI, ZXI. And for each, we have 5 choices. Color के 5 choices. How many total choices? 5 plus 5 plus 5 plus 5 plus 5 plus 5, 30. जो आंसर यहाँ पे आया, यही आंसर मैन्युअली लिस्ट करके भी आया कि कार, मॉडल एंड कलर्स. फाइन. तो टोटल 5, हर इस कार के इस मॉडल के 5 ऑप्शन, इस कार के इस मॉडल के 5 ऑप्शन, इस कार के इस मॉडल के 5 ऑप्शन, तो 15 ऑप्शन ये और 15 ऑप्शन, तो 30 ऑप्शंस इन टोटल. नाउ लेट अस गो बैक. द मॉडिफाइड क्वेश्चन हमने मॉडिफाई किया. व्हाट इफ द डीलर सेज कार A does not come in black? How many options does she have now? अब क्या बोलता है डीलर? कार A does not come in black. तो कार A में ब्लैक है ही नहीं चॉइस. So what do I have? यहां पे 4 में से 3 ही कलर है, यहां पे भी 4 में से 3 ही कलर है, यहां पे भी 4 में से 3 ही कलर है. 3 ऑप्शंस आर लेस. तो आंसर शुड बी 15 plus 12, 27 है ना. मैन्युअली काउंटिंग से तो आ जाएगी, इसमें ब्लैक कलर नहीं है बस. What about this? Can we now multiply? Can we now multiply? First you have to choose car, yes. Then we have to choose model, yes. And we have to choose color. But if you observe carefully, choice of color 4 है कि 5 है? That depends upon which car I choose. है कि नहीं? If I choose car A, then I have only 4 color options. If I choose car B, then I have 5 color options. Number of possible choices of colors is dependent on my choice of car. तो ये events independent नहीं बचे, because there are conditions on black color not being available in car A. So that puts additional condition on our multiplication principle. तो वो directly events independent नहीं है. We cannot do directly 2 into 3 into 5. What do I have to do? I have to make 2 separate cases. That अगर मैं कार A चूज करता हूं तो क्या होता है, एंड कार B चूज करता हूं क्या होता है. I can either, if I am Kritika, I can choose car A or I can choose car B, right? और मतलब एडिशन, तो कार A के चॉइसेस प्लस कार B के चॉइसेस ऐड होंगे. If I choose car A, I can choose any one of the 3 models, correct? And for each model I have 4 colors. Black available नहीं है, so there are 4 into 3 choices for car A. If I choose car A, I have 12 choices. And I can choose car A or car B, और मतलब addition. And car B करूंगा तो I have again 3 models and 5 colors. So it is 12 plus 15 is equal to 27, जो मैन्युअल काउंटिंग से भी आया. ये 12 प्लस ये 15. ठीक है. कार ए के लिए 12 चॉइसेस, कार बी के लिए 15 चॉइसेस, एंड आई कैन चूज कार ए और कार बी. व्हाई डू आई हैव टू सेपरेट these two cases? Because there is condition. The events, these 3 events do not remain independent if there is additional condition on color of car, depending on choice of car. Fine. I hope this is clear. This is our first section now in types of questions. कौन से type of question पूछे जाते हैं? This is again very popular type of question. Very popular type of question. Let us see. Very simple questions are there. Just pay attention. Just think. Now that you have background in addition and multiplication principle, just think on those lines and you'll be able to understand. First question. How many 3-digit numbers can be formed from 1, 2, 3, 4, 5? हमें क्या बनाना है? 3-digit number. We want to form 3-digit number. If you recall, in 3-digit number, we have hundreds place, tens place, and units place. Right? In the 3-digit number, there are 3 places, and we have to use digits out of 1, 2, 3, 4, and 5. Or first is, let us take first question, repetition of digit. Not allowed. Repetition of digits का मतलब क्या होता है कि एक डिजिट को एक ही बार यूज करोगे. यहाँ पे मतलब ऐसे 115 है, ये नंबर नहीं चलेगा, मुझे 1 2 बार यूज करके, ये नहीं चाहिए. मैक्सिमम यू कैन यूज 1 डिजिट वंस. एक डिजिट एक से ज्यादा टाइम यूज नहीं करोगे. दैट इज द कंडीशन. रिपीटेशन नॉट अलाउड का मतलब है कि वी कैन यूज 1 नंबर मैक्सिमम वंस, नॉट मोर देन वंस. सो वी हैव 3 प्लेसेस हियर. यू हैव 5 ऑप्शंस टू चूज फ्रॉम. और 3 डिजिट नंबर बनाने के लिए आई हैव टू चूज हंड्रेड्स प्लेस एंड टेंस प्लेस एंड यूनिट्स प्लेस, है कि नहीं? आई हैव टू चूज ऑल द 3. एडिशन सॉरी कौन सा प्रिंसिपल आएगा? मल्टीप्लिकेशन प्रिंसिपल. एंड दिस मल्टीप्लिकेशन एट द हंड्रेड्स प्लेस आई हैव 5 चॉइसेस. सारे चॉइसेस है मेरे पास. So I have 5 choices to choose from in hundreds place. Correct? Now ये 5 में से कोई एक यहाँ पे मैंने चूज कर लिया. बचे कितने? 4. रिपीटेशन इज नॉट अलाउड, सो आई कैन यूज ओनली वन ऑफ 4 नाउ. जो भी यहाँ पे यूज करके बचा है वो 4 ही यहाँ पे यूज कर सकता हूँ क्योंकि वो रिपीटेशन अलाउड नहीं है. सो हाउ मेनी चॉइसेस फॉर टेंस प्लेस नाउ? 4 चॉइसेस, बिकॉज यहाँ पे एक यूज कर लिया एंड रिपीटेशन इज नॉट अलाउड. Similarly, now units place, how many choices are there? 3 choices. यहाँ पे 2 यूज करने, 5 में से 3 बचे. और I have to choose hundreds place and tens place and units place. तो कितने choices हुए total? 60. I can form 60 numbers. Fine. If repetition is not allowed. What if repetition is allowed? If this is question, repetition is allowed, then what happens? Then again I have to choose 3 things. There are 5 options here. 5 options, these 5 options. And repetition is allowed. तो यहाँ पे भी 5 ही option है. अब repetition allowed है. वैसे ही यहाँ पे भी 5 ही option है. So total choices now 1, 2, 5. ठीक है. Simple. Simple. I hope you understand that if repetition is allowed, हर जगह पे 5 ऑप्शन से ऑप्शन कम नहीं होंगे, बिकॉज रिपीटेशन इज अलाउड. कितनी भी बार यूज कर लो कोई भी नंबर, तो 5 चॉइसेस, हर चीज के लिए 5 चॉइसेस रहेंगे. आई होप इट इज क्लियर. नाउ लेट अस मॉडिफाई दिस क्वेश्चन अ लिटिल. अगेन आई वांट टू फॉर्म 3 डिजिट नंबर्स. अगेन आई वांट टू फॉर्म 3 डिजिट नंबर्स, बट नाउ माय डिजिट्स आर 0, 1, 2, 3 एंड 4. क्वेश्चंस वही है. repetition not allowed. Second, repetition allowed. Fine. These are the 2 questions. Now Again, we start with hundreds place and we want to form 3-digit number. For 3-digit number, ये याद रखना कि for number to be a 3-digit number, क्या यहाँ पे 0 हो सकता है? नहीं हो सकता ना, because it will be a 2-digit number then. So here we have to have non-zero number. There is condition on hundreds place. Hundreds place 0 नहीं होना चाहिए. That is the condition. And whenever we are solving any question, we will ensure that first we fulfill the condition. बाद में ही आगे बढ़ेंगे. So for hundreds place, we want non-zero number. How many non-zero choices we have? 4 choices. Correct? So one of those 4 choices we use here. Now for tens place, how many choices remain? Out of 5, 1 is used here. Again 4 remain. यहाँ पे तो 0 आ सकता है, यहाँ पे tens place के लिए कोई problem नहीं है. So here also we have 4 choices. Do you understand why? Because one of the non-zero digits is used here. So out of 5, 4 choices remain. And here 2 have been used here. So 3 choices for this. So we have to choose hundreds place and the tens place and units place. So total choices 48. Fine. Question 1 का answer is 48. Next. Question 2, repetition is allowed. इसमें क्या होगा? Here we have again only 4 choices, not 5. Non-zero number has to come. Here we have 5 choices. Anything can come. And here also we have 5 choices. Repetition is allowed. Any digit can come any number of times. The number of choices is 100 here. I hope you understand the difference between question number 1, जहाँ पे 1 2 3 4 5 थे और जहाँ पे 0 1 2 3. वही लिखा है. You can read through it. In case of any condition, if we have any condition on the question, on any number of digits or on any position, we always start with the condition. We first ensure that while counting, condition gets satisfied and then we count. Now, जो वो example था हमें कि 3-digit number out of 0 1 2 3 4, we first have to ensure that number is in fact a 3-digit number, and thus we begin with hundreds place, put a non-zero number there, and then proceed with counting. That is how we count. We ensure that condition is fulfilled. बाद में ही बाकी चीजें करेंगे. Fine. Some variants of above question. How many 3-digit number divisible by 2 can be formed? Again, digits are same. If I have digits, let us say 1 2 3 4 5, and secondly I can have, चलो उस पे करते हैं, ब्लैक बोर्ड पे करते हैं. Here we have 1 2 3 4 5. Here we have 0 1 2 3 and 4. Question number 1 है numbers 3-digit numbers divisible by 2. Again उसमें सब question 1 है repetition not allowed. Here repetition allowed. Right? If I have these questions, ये भी है ना. So if repetition is not allowed, here we have 3-digit. We have to form 3-digit numbers. We have to form numbers divisible by 2. If number has to be divisible by 2, then units place has to be even number. मतलब 2 or 4 है ना? Then only number will be divisible by 2. So there are 2 choices for units place. Here we have started from the units place. Why? Because there is condition on units place. Correct? There is additional condition on units place. Then we can go anywhere. It doesn't matter now. 2 digits, 2 choices for this. One of them has been used. If repetition is not allowed, then we have 4 choices for this and 3 for this. This is the answer. 4 into 3, 12 into 2, 24. Correct. If repetition is allowed, then what happens? If repetition is allowed, then again we have 2 choices for here, then 5 for here, 5 for here. because repetition is allowed, so only 5 choices, any one of them can come here and here. So answer is 50. Correct. 5 into 5, 25 into 2, 50. Now let us come here. If repetition is not allowed, we want 3-digit numbers divisible by 2. Now number has to be divisible by 2, so it has to be even number. So units place has to be one of 0, 2 or 4, right? And there is additional condition which is inherently there, that hundreds place cannot be 0. Correct or not? If I have 0 here, if I have 0 at the units place, the number is even, and I don't have to worry about 0 being at the hundreds place, because 0 aa chuka hai yahan pe and repetition is not allowed. If here 2 or 4 comes, 0 is not there at the units place in the initial choice of even number, then I have to ensure that 0 yahan pe nahi aa raha hai. The choice at hundreds place still depends on that place, because there are two conditions here. Condition yahan pe even number ki bhi hai aur yahan pe non-zero ki bhi hai, because 0 is one of the choices. And because there are two conditions, I cannot apply two of them at the same time. I have to make cases. और cases क्या होंगे? Cases होंगे 1 and 2. One is here we have 0, and another here is, again we can separate only. Here we have 2, and another case is here we have. So we have two cases. We can have this or this or this, right? Because we want even number, so we can have these cases or these cases or these cases. We just need to add those cases. Now if you have 0 here, we have 4 choices for this and 3 for this, so total 12 cases. If you have 2 here, then we have out of 4 remaining, only 3 can come here, because 0 is not allowed there. Correct? 0 is not allowed to come at hundreds place. So here 3 choices, and here also 3 choices, because 2 are used. So it is 9. Here 12, here 9. Here also we'll have, here non-zero number can come, 4 is used here. So out of 0, 1, 2, 3, only 1, 2, 3 can come here, and the rest of them, 3 choices, we can come at tens place. So we have 9. 9 plus 9 plus 12, total 30 cases like this. I hope you understood why we had to separate the cases. अगर नहीं समझ में आ रहा है तो कोई बात नहीं, इतने difficult question UPSC ने अभी तक पूछे नहीं है. I'm just going through the questions. And if repetition is allowed, then what happens? Here we have 3 choices, any one of them even numbers can come, and here we have 4 choices, non-zero things can come. Here we have 5 choices. So 4 into 5, 20 into 3, total 60 choices. Correct? In this way, you can solve each of this question. Second question, how many numbers, 3-digit numbers not divisible by 2 can be formed? You know how many are divisible by 2? Just from total number subtract divisible by 2, you will get not divisible by 2. Simple. How many 3-digit numbers divisible by 5 can be formed? If I have 1, 2, 3, 4, 5, and if I want number to be divisible by 5, so यहाँ पे 5 ही आना चाहिए. Only 5 can come here, so there is only one choice. No other choice can come. So we only have these choices. यहाँ पे if repetition is not allowed, we have only 4 choices here, because one of them is used here, and here we have 3 choices. So total 12 choices. If repetition is allowed, then we have 5 choices here and 5 choices here. Total choices 25. Simple. And if we have 0, 1, 2, 3, 4, then what happens? Then only 0 has to come here. Then we don't have to worry about 0 there if repetition is not allowed. If repetition not allowed, 4 choices here, 3 choices here, we have 12. If repetition is allowed, 4 choices here, 5 choices here, you have 20. I hope you are understanding this. Last, how many 3-digit numbers greater than 300 can be formed? For number to be greater than 300, hundreds place has to be 3, 4 or 5. Correct? Just ensure that hundreds place पे 3 choices है बस, बाकी सब same रहेगा. So last thing, what if we have 5 digits, like we have to form 5-digit numbers. 5-digit number form करना है out of 1, 2, 3, 4, 5. Then we have 5 choices for this, 4 for this, 3 for this, 2 for this, and 1 for this. Total number of ways कितना है? 5 into 4 into 3 into 2 into 1. इसे क्या बोलते हैं? इसे बोलते हैं 5 फैक्टोरियल। सिंबल है एक, सिंबॉलिकली ऐसे लिखा जाएगा 5 फैक्टोरियल को। तो इफ यू वांट टू फॉर्म लेट अस से 5 डिजिट नंबर आउट ऑफ दिस 5 डिजिट्स, तो ये बस इन सारे डिजिट का रीअरेंजमेंट होगा, एक इधर आएगा एक उधर आएगा, मतलब किसी ना किसी ऑर्डर में, दैट विल बी जस्ट रीअरेंजमेंट ऑफ दिस 5 डिजिट्स और नॉट। If I have to form 5 digit number out of these 5 digits, then it will be just rearrangement of these digits, and number of such rearrangements is what? 5 factorial. So in general, if we have n things, n items or anything, n digits, and we just have to rearrange them, एक दूसरे के साथ rearrange करना है, so there are n factorial number of ways to rearrange. और वो कैसे आता है n factorial? ये ऐसे आता है, 5 choices for first, second के लिए 4 choices, third के लिए 3, 2 into 1. So this is how 5 factorial comes from multiplication principle. As in, there are exactly n factorial ways of arranging n symbols or objects. And this is a different question. So I wanted to discuss it. Question is, how many factors of this multiplication are multiples of 120? तो कैसे करना है ये देखो बस, 28, 36, 54, 105. And we want to find out how many factors of this number are multiples of 120, right? So what are the factors of this number? To find out that factors, we just need to recall our discussion from arithmetic chapter, जहां पे हमने prime factorization के time पे ये किया था. Let us factorize this prime factorization. find करते हैं. This is 28 is 4 into 7, 36 is 4 into 9, 54 is 2 into 3 cube, 27 into 2, and 35 is 3 into 35, na? 3 into 35 is 3 into 5 into 7. Fine. So in total, this number, this multiplication is 2 to the power 2 plus 2, 4 plus 1. So 2 to the power 5 into 3 to the power 2 plus 3, 5 plus 1, 6 into 5, एक ही बार आया, and 7 we have 2 times. This is the number we have. And 120 is what? 2 cube, 15 8s are, na? 15 into 8. 8 into 15. 15 is 3 into 1. This is what? 120. Now recall that we had said that if we call this number n, then any factor of this n, how will that factor look? 2 की कुछ पावर into 3 की कुछ पावर into 5 की कुछ पावर into 7 की कुछ पावर. This factor, any factor of this number will look something like this, क्योंकि इसके पास जो प्राइम नंबर है वही प्राइम नंबर फैक्टर के पास भी होंगे, नए तो नहीं होंगे एडिशनल. Factor will always have only one of them as prime factors. It won't have any additional prime numbers as factors, है ना? So factor ऐसा ही दिखेगा, and that too ये 2 की जो पावर है वो फैक्टर में 5 से कम होगी, मैक्सिमम 5 होगी, मतलब it can be 0 to 5, 0, 1, 2, 3, 4 और 5. 3 की पावर it can be only maximum 6, 5 की पावर maximum 1 हो सकती है, and 7 की पावर maximum 2 हो सकती है. Any factor has to look maximum that way, that 2 की पावर maximum 5, 3 की पावर maximum 6, 5 की पावर maximum 1, 7 की पावर maximum 2. This is how factor of this number will look like, correct? Because of prime factorization. And we want 120 to be factor of this number. Fine. 120 क्या है? 2 की पावर 3 है. For 120 to be factor of this number, factor का factor होने के लिए 120 इसमें होना चाहिए. 120 has to be there. So basically 2 at least 3 times होना चाहिए. And it can be maximum 5. So यहाँ पे 2 क्या क्या आ सकता है? 3 आ सकता है, 4 आ सकता है या 5 आ सकता है. 3 बार तो होना ही चाहिए ना for 120 to be factor. Then for 120 to be factor, 3 at least once has to come. So 3 can be 1, 2, 3, 4, 5 or 6. At least 1 होना चाहिए. And 5 also at least 1 होना चाहिए, वो 1 ही हो सकता है. यहाँ पे भी 5 होना ही चाहिए, यहाँ पे मैक्सिमम 1 ही हो सकता है, तो एक बार ही होना चाहिए। एंड 7 कैन बी एनीथिंग, 7 के लिए कोई कंडीशन नहीं है, so it can be 0 or 1. Fine. And we have to choose this box, power of 2 and power of 3 and power of 5 and power of 7 for every factor. तो कितना ऑप्शन है इसके लिए? 3 options for this. इसके लिए 3 plus 3, 6 options for this. Here only 1 option and here we have 2 options. 6 into 3, 18 into 2, 36. So there are 36 factors of this number n, जो भी ये दिया गया है, which are multiples of 120, and this includes 120 as fine. 120 कैसे आएगा? यहाँ पे 2 की पावर 3, 3 की पावर 1 and 5 की पावर 1, 7 की पावर 0. So that combination if you took, then we have 36. सारे combinations इस multiplication में include हो चुके हैं. I hope you understood. कैसे करना है आप मुझे लगता है समझ गए होंगे कि फैक्टर पहले प्राइम फैक्टराइजेशन करो, उसका भी करो, और फॉर एवरी फैक्टर टू बी मल्टीपल ऑफ दिस, द पावर्स ऑफ प्राइम नंबर्स इन द फैक्टर्स हैव टू बी एटलीस्ट दैट नंबर, क्या एटलीस्ट 3 बार आना ही चाहिए टू, तो वी कैन हैव 3, 4 और 5, यहाँ पे मैक्सिमम 5 है, यहाँ पे एटलीस्ट 1 आना चाहिए, तो 1, 2, 3, 4, 5. अगर 7 का देखो, जैसे वहां पे 7 की पे कोई कंडीशन नहीं है, 7 मे बी देयर मे नॉट बी देयर, इट डजंट मैटर, सो 7 कैन बी 0 और 1. 120 में तो 7 है नहीं, तो इसलिए 7 वहां पे एक बार भी नहीं है, कंडीशन कुछ नहीं है, तो ये 7 कैन बी 0 और 1, बोथ आर 5. Here options are wrong, please ignore that. Fine. I hope you are with me. So today, then again, now we'll start with new section, which is called anagrams. Again, very simple, very standard questions are come. Very standard questions are being asked in this section. तो अच्छे से करोगे, प्रैक्टिस करोगे, थोड़ी आराम से हो जाएगा, बहुत आसान है, और जो हमने अभी मल्टीप्लिकेशन प्रिंसिपल में किया, मोर और लेस उसका ही एक्सटेंशन. What is anagram? Okay, first question is what is anagram? Anagram कुछ नहीं है कि we have some letters with us. Let us say U, P, S. These are 4 letters we have in front of us. So what will be the anagrams of this? We can have U, S, P, C. We can have U, C, P, S. We can have C, S, U, P. We can have C, U, P, S, etc. etc. These are all called anagrams of this word. Anagrams मतलब letters का rearrangement. That is all. I hope you understood what anagram is. एक दूसरे letters को बस घुमाना आपस में, rearrange करना, letters rearrangement is your anagram. And question वही होता है, in how many anagrams are possible for this word? So because UPSC it is 4-letter word, all the 4 letters are different. तो बेसिकली अरेंजमेंट होगा, हमने क्या देखा था ऊपर, नंबर ऑफ पॉसिबल अरेंजमेंट ऑफ n सिंबल्स और ऑब्जेक्ट्स और डिजिट्स क्या होता है, n फैक्टोरियल होता है, तो नंबर ऑफ पॉसिबल एनाग्राम शुड बी 4 फैक्टोरियल. अगर 4 लेटर वर्ड है तो 4 फैक्टोरियल होगा, उसमें कौन सी बड़ी बात है, तो इट इज 24. करेक्ट. वी कैन एनलिस्ट एज वेल सारे एनाग्राम, उसमें कोई बड़ी बात नहीं है, कैन एनलिस्ट एज वेल. इफ यू टॉक अबाउट यूपीएससी, वी कैन एनलिस्ट ऑल द एनाग्राम. इफ यू स्टार्ट विथ let us say UPS, then we can say first is U, then P, C, then U, S, P, then U, S, C, then U, C, P, S, then U, C, S. ये हो गए 6 with U as the first letter. वैसे P as the first letter के 6 होंगे, S as the first letter के 6 होंगे, C as the first letter के 6 होंगे. So total we'll have 24 anagrams of UPSC. ठीक है, एनलिस्ट भी कर सकते हो, कोई प्रॉब्लम नहीं, बट वी डोंट नीड टू बिकॉज देयर आर 4 सिंबल्स, U, P, S, C, 4 लेटर्स है, चारों अलग है, सो इट इज स्ट्रेट अवे 4 फैक्टोरियल होगा. 4 फैक्टोरियल क्या होता है, 4 into 3 into 2 into 1 which is 4 into 3 12, 12 into 2 24, 24 into 1 20. तो वैसे ही हमें 24 आंसर is known to us. So that is how anagrams need to be counted. 4 letter word है, we have to rearrange, it is 4 factorial. But इतने से काफी नहीं है. Of course there are some additional conditions which we may need to incorporate. Above question is same as having n letters and finding out how many ways are there to arrange without repetition. So it is n factorial. Now what about other questions? जैसे कि find anagrams beginning with or ending with a vowel, or find anagrams with all the vowels together, or vowels at third and fifth position, etc. ये सारे उसके variations हो सकते हैं. Variants of these questions can get asked, but let us see how to solve them very simply. First question, we'll solve through questions only. How many anagrams can be formed from the word Delhi? D-E-L-H-I. 5-letter word, no repetition, so it is simply 5 factorial, which is 120. No need to think about it. Now comes the important part. How many anagrams can be formed from this word Mumbai? Delhi तो 5 factorial 120 है. Mumbai क्या है देखते हैं. We have M U M B A. This is a 6-letter word. 6-letter word. But here there are 2 letters which are same. मतलब यहाँ पे M 2 बार आ रहा है. We don't know how to do that. अभी तक हमें क्या पता है? We only know how to do questions where all the letters are different. We don't know how to solve if the letters are not, if the letters are same. So let us make them different from our side. Let me call this M1. Let me call this M2. अब हो गया, सारे letters different हो गए. Correct. Everything is now different. So what happens? How many anagrams? 6 factorial. कोई tension. 6 factorial anagrams. Fine. But हमें पता है कि हमने झोल तो किया है कुछ. We know that we have modified the question. We are not solving the same question. So what have we changed and how to rectify that? Now, let us look at this word M1 U, M2 B A I, and let us look at this M2 U, M1 B A. Rest of the letters I have put at the same places. I only switched M1 and M. अब ये in this 6 factorial, these 2 anagrams have been counted as separate. Correct or not? Because हमने यहाँ पे कुछ condition डाला ही नहीं ना. सारे ही हमने count कर लिए different तरीके से. तो ये और ये से different ही count होंगे ये 6 factorial में, because हमने नाम दिए दोनों को M1 M2. So these 2 will be counted as different anagrams in this 6 factorial. But reality में क्या हुआ है? Reality में हमें तो पता है ना कि both are same. ये तो M1 1 और 2 तो मैंने डाला अपने साइड से. These M's don't know that they are M1 and M2. They are actually exactly same. है ना? So this M1 and M2 and M2 and M1, this actually is the same anagram, but I have counted it twice. This actually is these 2 are actually same anagram, but I have counted it twice. So for every anagram, this has happened. हर चीज के लिए ऐसा हुआ है कि मैंने एक बार ही काउंट करना था, लेकिन मैंने 2 बार किया. क्यों किया 2 बार? Because I have called them M1 and M2, but actually they should have been counted only as once. तो मेरे से पूरा डबल काउंटिंग हुआ है जितना होना चाहिए. Exactly डबल काउंटिंग हुआ है. Keeping everything else at the same location, M1 and M2 and M2 and M1 will give me 2 different anagrams, but actually they are exactly same anagram. तो कोई भी आप ले लो anagram. ये तो मैंने एक ले लिया ऐसे ही. आप जैसे कि कोई और ले लो. B M1 U A M2 I. ठीक है. This is again another. And for this, if I write this, these 2 I have counted as separate, but actually they are same. क्योंकि M1 M2 कुछ है ही नहीं. So for every same position of other letters, अगर मैं M1 और M2 को replace कर दूं एक दूसरे से, तो I have counted them as 2 anagrams, but actually they are only 1 anagram. तो हुआ क्या है कि हर चीज मैंने 2 बार काउंट की है, जो मुझे नहीं करनी चाहिए थी, और उसको रेक्टिफाई करने के लिए मैं जस्ट आई डिवाइड बाय 2. तो 2 बार का काउंटिंग मैंने हाफ कर दिया. दैट इज द नंबर ऑफ एनाग्राम्स दैट आई हैव ऑफ दिस वर्ड मुंबई, व्हिच इज व्हाट 6 फैक्टोरियल क्या है 720 है डिवाइडेड बाय 2. It is 360. Actually, anagrams are positive. Fine. Fine. I have written that only here. You can read about it. Now, Kolkata. Next city is Kolkata. 1, 2, 3, 4, 5, 6, 7. 7 letters are there. तो वैसे तो 7 factorial होने चाहिए anagrams, but here K has come twice and A has come twice. Again, I can do K1, K2, A1, A2, but again same problem हुआ जो मुंबई में हुआ था, तो वो problem rectify करने के लिए I have to divide by 2 factorial 2 times. ये K के लिए, ये A के लिए. That is your answer. 7 factorial divided by 4, 2 into 2. जो भी है, you can compute it numerically as well, but that is how it works. How about Bengaluru? Bengaluru, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 factorial for 9 letter word. And what has happened? What has repeated? यहाँ पे U has been repeated 2 times. Nothing else is repeated. है ना? Right? Only U has been repeated, so it is divided by 2 factorial. Bas, that is all. Next is Q. 5 factorial divided by, this is for U, this is for E. Fine, this is the answer. Next, access. This is 3 plus 3, 6. So 6 factorial divided by 2 for C, 2 for S. This is the answer. Then Erie. Erie is 1, 2, 3, 4, 5, 6. So 6 factorial divided by 2 for I and E के लिए 3 factorial. But ये याद रखना, this is factorial, 3 factorial. Why is this factorial coming? Because if I put E1, E2, E3 there, so I can rearrange them in 3 factorial ways, not 3 ways, 3 factorial ways. E1, E2, E3 तीन चीजें अगर same आ रही है, तो every rearrangement of them is actually same. जैसे मुंबई के केस में 2 ही चीजें थी, M1 and M2 थे, तो M1, M2 को replace करके we have just 2 arrangement. But if I have this, तो जैसे कि ईरी कोई और ले लेते हैं, चलो A, B, C, A, D. If I have this word and I have to find rearrangement, so D, B हटा देते हैं, this 5 letter word there. And I'll do this A1, A2, A. Then I can have A1, B, C, A2, A3, A1, B, C, A3, A2. Then A2, B, C, A1, A3, A2, B, C, A3, A1, A3, B, C, A1, A2, A3, B, C, A2, A. ठीक है, if you look at it now, क्योंकि ये A1, A2, A3 आपस में मैंने rearrange करवाए हैं, and we have 6 possible arrangement. But actually, if you look at this word, ये A1, 1, 2, 3 तो मैंने डाला है ना, A तो सारे same ही है, तो this should have been calculated only as once. कि ये anagram count होना चाहिए था बस, इसमें 1, 2, 3 कुछ है ही नहीं, तो ये सबका मतलब यही है, बट मैंने अपने इसके लिए 1, 2, 3 डाला, तो 1, 2, 3 डालने की वजह से क्या आया, 5 factorial आया, बट A has been there 3 times, so उसके सारे rearrangement A1, A2, A3 के कितने हैं, 6 है. It is not 3, it is 3 factorial rearrangements are there, so that is why I have to divide by 3 factorial. वही है, यहाँ पे ईरी है तो 6 factorial, 2 factorial for these 2 i's and 3 factorial for 3 times e. हाँ, next question देखो, how many anagrams can be formed from the letters of tree such that all vowels are together? अब क्या चाहिए मुझे, I want anagrams of tree R, E, E, but all vowels together. That is the condition. I want all vowels to be together. Vowels कौन से हैं? E and E. I want them together. So अगर ऐसे ही उनको छोड़ दूंगा तो I cannot ensure that they are together. So what do? I treat them as a block.
मैं उनको एक ब्लॉक की तरह ट्रीट करता हूँ कि ये दोनों एक बक्से में बंद है, दे आर नाउ इन अ ब्लॉक, सो दे विल एक्ट एज वन, बिकॉज whenever they will be moved in as a block, तो वो हमेशा साथ रहेंगे, ठीक है। तो how many rearrangements? This is 3, 1, 2 and 3, so 3 factorial rearrangements. Is there any repetition? No, now अब नहीं है repetition because this is one block which is separate from T and R, so no repetition. And inside the block both are same, E and E, so they can be, there is only one way to write that, so it is only 3 factorial, so 6 ways are there. So basically ऐसा होगा T R E E as a block, then T block, block में अंदर E E आएगा, यहाँ पे R, फिर यहाँ पे we can have R T, यहाँ पे E E as a block, then R, यहाँ पे block, and यहाँ पे T, then finally we have block R T and then as a block T and R. These are 6 ways we can have these rearrangements. Next question, उसका ही थोड़ा सा modification. कोलकाता such that all vowels are together. अब देखते हैं कोलकाता में क्या होता है. कोलकाता है, हमें we want all vowels to be together. Vowels कौन से हैं? We have O, we have A and we have E. So let us club them. We have K, L, K, T, and in a box we have O, A, A. They have to come always together. Fine. So now we have 1, 2, 3, 4 and 5 things. So we have 5 factorial rearrangements. But K has been repeated. So reduced by 2 factorial. And but you look at this inside. For every such rearrangement, we have OAA inside. अब उनका भी तो rearrangement हो सकता है अंदर के अंदर. We can have OAA और AOA etc. ये सारे चीजें हो सकते हैं अंदर के अंदर. For every KLKT, we can have OAA, AOA और सारे multiple होंगे फिर. तो उसके हिसाब से how many rearrangements of inside are possible? We have 3 factorial because 3 things, but A has come 2 times, so reduced by 2 factorial. We have to rearrange this and का मतलब multiply. So this is the answer. We have 120 by 4 into 3. So it is 90. Correct? That would be the answer. How many anagrams can we form from the word football such that all vowels are together? Again, one more question. We have football. We have F, T, B, L, L, and inside the block we have O, O, A. So we have 3 plus 2, 5 plus 1, 6, 6 factorial by L has come 2 times, and inside rearrangements we have 3 factorial by 2 factorial. This is the answer. I hope you have understood this. We'll move to next section. Next section is very similar to this particular section, anagram. In anagrams we had letter and their rearrangements. Here we have people and their rearrangements. Linear sitting. Basically question is how many ways are there to sit 6 people A, B, C, D, E, F on 6 chairs. We have 6 chairs, we have 6 people. So basically all 6 of them will sit and they can just rearrange among themselves. So how many ways are there to rearrange? 6 factorial, right? We know that number of possible rearrangements of n different people will be 6 factorial. Just like Delhi, 5-letter word tha. How many rearrangements were possible? How many anagrams were possible? 5 factorial. Similarly, here we'll have 6 factorial. But again, now we will modify, we'll put some restrictions, some conditions. Question: how many ways are there to sit 6 people on 6 chairs? If A and B always sit together, what will happen? If A and B always sit together, A, B, C, D, E, F, and A and B want to sit together on the 6 chairs, then we will treat them as a block and then rearrange them in as a block only. So how many things we have? 5 factorial. But A and B can be rearranged them in among themselves. So we can rearrange themselves in the 2 factorial number of ways because there are two things rearrangement, 2 factorial. So now answer would be 5 factorial into 2, 240. Fine. Next, how many ways are there such that if A and B don't sit together? Now, don't sit together. How to ensure that they don't sit together? It is simple. Just find the total number of arrangements and subtract the cases where they sit together. अगर वो जब साथ है वो वाले केसेस हटा दिए टोटल में से, तो जब साथ नहीं है वो वाले आ जाएंगे. So there are total cases are 6 factorial because 6 people 6 chairs minus when they are together 5 factorial into 2 factorial. अभी subtract किया था हमने ऊपर, अभी फाउंड किया था. So it is 720 minus 240 is 480. That would be the answer of this question. Next, how many ways are there to sit 6 people on 4 chairs? Now, chairs are less, people are more, right? So we have chair number 1, 2, 3 and 4. People are 6. A, B, C, D, E, F. है So if you look at it from the chairs perspective, for chair number 1, C1, C2, C3, C4. How many options for this chair number 1? 6 options. For chair number 2, 5 options. For chair number 3, 4 options. Chair number 4, 3 options. This is it. Just like forming the numbers. जो भी है 6 into 5 into 4 into 3. Only 360. Fine. I hope this was clear. And let me take a 5-minute break, and we'll then start with the next section where we will start using the terms permutation and combination. Till now, we have not used once these terms permutations and combination. We were just counting. We were just using multiplication and addition principle. Now I'll introduce these terms to you. Sometimes it simplifies the calculation. Guys, we'll start with next section, permutation and combinations. What do we mean by these terms? A permutation of a set is, loosely speaking, an arrangement of its members into sequence or linear order, or if the set is already ordered, rearrangements of its elements. Basically, permutation क्या है? Permutation is rearrangement where order is important. Rearrangement ही है अपने कोई एक set है उसके elements का rearrangement is the permutation. And वहाँ पे order is very important. For example, 135 is a different than 315. Elements वही है 135, 1315. Choice of 3 digits is same, but these two will be counted as different permutations because in permutation order is very, very important. So let's take our linear sitting वाला example जो अभी हमने लिया था. There are 6 chairs. Sorry, there are 6 people, but only 4 chairs. Then how many ways are there to sit these 6 people? 4 chairs थे and लोग 6 थे. A, B, C, D, E, F. So how many ways are there? We said that for this we have 6 choices. For this chair we have 5 choices. Out of them, here we have 4. Here we have, and total number of ways hence is this. तो हम क्या कर रहे हैं यहाँ पे? 6 into 5 into 4 into 3. मैं यहाँ पे to write it shortly, I am multiplying by 2 into 1 and then dividing by 2 into 1. So it is same as 6 factorial by 2 factorial. ये 6 factorial लिखने के लिए मैंने multiply किया, divide किया, right? This 6 factorial by 2 factorial is nothing but 2 factorial को मैं कैसे लिख सकता हूँ? 6 minus 4. 6 were people, 4 were chairs. So 6 minus 4 factorial. So this is what permutation is. Notice that order of person sitting on the chair is important here. So मतलब A, B, C, D is different from C, A, B, D. Permutation में order is always very, very, very important. Fine. This is permutation. मतलब definition के wise ये है. If we have to choose R things out of n without replacement or repetition, and where order is important, then number of ways are npr or n factorial by n minus r factorial. यहाँ पे क्या था? There are 6 people, 4 chairs. So firstly we have to choose कौन 4 लोग बैठेंगे. Firstly we have to choose कौन 4 लोग बैठेंगे, and we have to choose R things out of n देन विदाउट रिप्लेसमेंट और रिपीटेशन, मतलब 4 लोग चूज कर लिए, वापस रखना नहीं उनको। वेयर ऑर्डर इज इंपॉर्टेंट, क्योंकि चेयर्स लिनियर सीटिंग है ना, लाइन से रखी गई है, तो कौन पहला बैठेगा, दूसरा, तीसरा, दैट इज इंपॉर्टेंट, ऑर्डर इज इंपॉर्टेंट। So there are NP or R or 6P, 4 ways of doing it, which is equal to 6 factorial divided by 6 minus 4 factorial, which is 6 factorial by 2 factorial. ये जो हमें पहले भी मिला था. This is what permutation is. Permutation क्या है? We have to choose R things out of N things, and we have to then order. We have to arrange them as per some defined order. ये है permutation. Then there are number of ways of doing it is NPR or N factorial by N minus R factorial. ये definition of permutation. ठीक है. बट ये क्वेश्चन करने के लिए जो हमारा लिनियर सीटिंग वाला था, जरूरी नहीं है कि आप NPR ही करो. आप अब हमने जैसे ऊपर किया वैसे भी कर सकते हो, वो सिंपल लग रहा है वो करो. देयर इज नो नीड टू यूज NPR ओनली. मतलब NPR यूज करना ही चाहिए ऐसा कोई नहीं है ना, बिना यूज करे भी आंसर आ जाता है. इट इज बेसिकली मल्टीप्लिकेशन प्रिंसिपल एंड एडिशन. मैंने वही बोला था स्टार्टिंग में, प्रिंसिपल्स इंपॉर्टेंट है, बाद में जो भी करेंगे वो उसी से निकलेगा इन वन वे और द अदर. देन वी कैन रिविजिट आवर ओल्ड सेक्शन. जैसे फॉर्मिंग नंबर्स वाला जो सेक्शन था, वहां पे क्वेश्चन इज हाउ मेनी 3 डिजिट नंबर्स कैन बी फॉर्म फ्रॉम 1 2 3 4 5 विदाउट रिपीटेशन. सो यहाँ पे करना क्या है, we have 5 digits but we have to form 3 digit number. So from 5, firstly we have to choose 3 digits and then we have to permute them. So it is 5p3. 5p3 क्या होता है, 5 factorial by 5 minus 3 factorial, which is 5 factorial by 2 factorial, which is 60. वो वही आया था हमारा 5 into 4 into 3, 60 ही आया था. तो NPR भी कर सकते हो सीधा, 3 डिजिट्स है, इसके लिए 5 चॉइस, इसके लिए 4 चॉइस, इसके लिए 3 चॉइस, ऐसे भी 60 कर सकते हो, कोई प्रॉब्लम नहीं है. बोथ विल गिव यू सेम आंसर, जो भी आपको सही लगे कर सकते. Now let us modify the question a bit. How many ways are there to choose 3 numbers from 1 2 3 4 5? पहले क्वेश्चन क्या था, how many 3 digit numbers can be formed, and here what we are saying, we just have to choose 3 numbers. Their question was 3 digit numbers. 3 digit number के लिए क्या होता है, whenever we say 3 digit number there is hundreds place, tens place, units place. 3 digit number में वो होगा ना, अलग अलग होगा, तो order will be important. 123 and 213, there will be, these are two different numbers, but in as far as choice goes, both of them same choice of digits है, 1 2 3 है ना. So if the question is how many ways are there to choose 3 numbers, क्या करना है, मुझे 5 numbers है, I just have to take 3 and put them in my pocket. मेरा बाकी कोई intention नहीं है, I don't want to order them, I just have to make a choice and keep that in my pocket. So in that case we don't have to form 3 digit number, we just want to choose this number. Is order important? The choice 1 2 3 and 2 1 3 are absolutely same, क्योंकि same digits है, मुझे तो choice चाहिए बस. I just want choice of digits. I'm not at all concerned about the order. I don't want to form the 3 digit numbers. I just want to take these digits and put them in my pocket. So same digits है, 1 2 3 हो, 2 2 1 3 हो, these are same. If all such permutations of any 3 chosen numbers are same, we need to ensure that there is no double counting. When we permute, permutation में order important होता है, लेकिन choice में order important नहीं है. choice तो बस choice है. So number of ways 3 chosen numbers can be rearranged, वो क्या है, वो हटाने पड़ेंगे. जैसे हमने anagrams में किया था कि whenever there were repetition of digits, we used to divide by some factorial, ताकि rearrangement सारे हट जाए और बस unique choice मिल जाए हमें. M1 M2 सेम है मुंबई में, तो 2 factorial से डिवाइड करो. अगर 3 times E है तो 3 factorial से डिवाइड करो, so that all those rearrangements should be counted only as one. यहाँ पे वही करना है कि यहाँ पे 5p3 is number of ways we can form 3 digit numbers. तो order important हो गया, but if I want to remove all the ordered pairs, we just have to divide by 3 factorial, क्योंकि 3 digits है, उनके 3 factorial rearrangements हो सकते हैं. I have to count that only as one, equal to 5 factorial by, this is 5 minus 3 factorial and this is 3 factorial. इसको क्या बोला जाता है? इट इज कॉल्ड एज 5 चूज। दिस इज डेफिनेशन ऑफ 5C3। ठीक है, 5P3 by R factorial or 3 factorial. The combination is way of selecting items from a collection such that the order of selection does not matter. The order of selection does not matter. In such case, number of ways of choosing R items out of N items is NCR or N choose R, which is N factorial divided by R factorial into N minus R factorial, which is same as NPR divided by R factorial. यहाँ पे NPR हमेशा NCR से बड़ा होगा ऑब्वियसली, बिकॉज NPR डिवाइडेड बाय R फैक्टोरियल है वो, तो R फैक्टोरियल से डिवाइड होकर वो जो नंबर आ रहा है वो छोटा ही होगा। NPR इज ऑलवेज ग्रेटर देन NCR एंड NCR इज सेम एज N चूज N माइनस R। ये दोनों चीजें याद रखना, NCR इज सेम एज N चूज NC N माइनस R। जैसे कि फॉर एग्जांपल 5C3 इज सेम एज 5C, क्योंकि ये क्या है 5 फैक्टोरियल डिवाइडेड बाय 3 फैक्टोरियल into 5 minus 3 factorial, which is 2 factorial। और ये क्या है 5 factorial divided by 2 factorial into 5 minus 2 factorial, which is 3 factorial। So both are actually exactly same quantity। ठीक है, so here selection में order of selection does not matter, but we just have to choose R items out of N item। order important नहीं है, then we'll just choose NCR यूज करेंगे, जहां पे ऑर्डर इंपॉर्टेंट है वहां पे NPR यूज करेंगे, वहां पे परम्यूटेशन यूज करेंगे। और परम्यूटेशन मोस्ट ऑफ द टाइम्स यू मे नॉट नीड टू यूज, बिकॉज हमने ऑलरेडी वो बेसिक्स मल्टीप्लिकेशन प्रिंसिपल से कवर कर लिया है। तो इफ यू आर कंफर्टेबल यूज दैट ओनली, एंड इफ यू आर कंफर्टेबल इन यूजिंग परम्यूटेशन फॉर्मूलाज, यूज परम्यूटेशन फॉर्मूला, बट NCR इन प्रैक्टिकलिटी मे बी मोर यूजफुल देन NCR। Permutations are for lists, वहां पे order matter करती है, and combinations are for groups where order does not matter। Combinations are easy going, order doesn't matter, you can mix up and it looks the same। तो combination है बस group of people, वहां पे combination important, मतलब जो choice important है लोगों का, किस order में लोग select हो रहे हैं वो important। Permutation is arrangement where order matters, combination is selection or choice where order is irrelevant। तो यू नो अ कॉम्बिनेशन लॉग, उसे एक्चुअली परम्यूटेशन लॉग बोलना चाहिए, क्योंकि वहां पे ऑर्डर मैटर करता है। Fine. Another sample question: if we have 8 different chocolates and we want to give it to 3, we want to give 3 out of them away, how many ways are there to do this? 8 chocolates है, 8 different chocolates, okay, we have 8 different chocolates and we have to give the 3 out of them away। how many ways are there? 8 में से 3 देने हैं ना, किस ऑर्डर में देने that is not important, we just want to give 3 away, so choose any 3 out of these 8। so we have 8C3, choose any 3 chocolates out of these 8 and give them away। चूज ही करने हैं ना, and give them away। अब किसको देने, कितने लोग को देने, that information is not there, so order is not important, we just have to give them away। ये तो मतलब फेंक देने ऐसे भीड़ में, that doesn't matter, we just have to choose 3 and give them away। that is the first question। 8 different chocolates, so we have to make a choice, 8 में से 3 choose करो and rest of them we have to distribute it in some way। but what if we want to choose these chocolates and give them to Raju, Shyam and Babu Rao, right? if we have to give these 3 chocolates to Raju, Shyam and Babu Rao, now it matters कि कौन सा चॉकलेट किसको दे रहे हो। अब ऑर्डर डिफाइन हो गया, क्योंकि 3 अलग अलग लोग उसने डिफाइन कर दिए क्वेश्चन में, तो ऑर्डर आ गया कि राजू को मैं पर्क दूं या फिर मंच दूं या फिर कोई 5 स्टार दे दूं या फिर किसको क्या दे दूं आउट ऑफ दिस 8। सो दैट मैटर्स नाउ कि किसको क्या चॉकलेट मिलता है, बिकॉज दिस पीपल डिफाइन द ऑर्डर। तो क्या होगा वो होगा 8P3, या फिर इसे 3 फैक्टोरियल से मल्टीप्लाई करोगे। सिमिलर सेम थिंग 8p3 या फिर 8c3 इंटू 3 फैक्टोरियल, जो भी चॉकलेट दिए गए हैं उन तीनों को जस्ट रीअरेंज देम। आई होप यू आर अंडरस्टैंडिंग दिस। नेक्स्ट सैंपल क्वेश्चन अगेन देखो, देयर आर 7 बॉयज एंड 9 गर्ल्स, ओके, एंड वी वांट टू चूज 4 बॉयज एंड 4 गर्ल्स। हाउ मेनी वेज आर देयर टू चूज? ठीक है, so we just have to choose. Question itself is saying, question is not saying कि किस ऑर्डर में चूज कर रहे हो, किस चीज के लिए सिलेक्ट कर रहे हो, that is not given. It is just choose ही बोला है क्वेश्चन में, choose 4 boys and 4 girls. If you select any 4, is the order important? Not important at all. We just want to select. उनके साथ क्या करना है वो हमें नहीं बताया है। अगर ऐसा क्वेश्चन बोल दे कि 4 लोग को सिलेक्ट करना है और लेकिन उनको रैंक देना है 1 2 3 4 उसी रेंज उसी सीक्वेंस में वो लोग लेट अस स्पीच देने जाएंगे, देन ऑर्डर इज इंपॉर्टेंट, पहला किसे करते हो दूसरा किसे करते हो। बट हियर दे आर जस्ट सेइंग चूज, वी जस्ट वांट टू चूज 4, so we want to choose 4 boys out of 7, 4 boys out of 7, so there are 7c4 ways, and मतलब multiplication, and 4 girls, so 9c4, so this is the number of ways of choosing these. Then how many ways are there to choose 2 balls from 5 identical red balls? यहाँ पे बहुत बार आपको फंस सकते हो आप कि how many ways are there to choose 2 balls from 5 identical red balls? 5 identical red balls है, एकदम identical है, तो does it matter कौन से तो चूज करते हो? Does it matter? No, all the choices are exactly same. कोई भी 2 बॉल ले लो ना, there is only one choice. There are identical red balls. Identical चीजें होती है तो एक ही चॉइस होता है, तो पता कैसे चलेगा चॉइसेस डिफरेंट है कि नहीं? तो only there is one choice. There is only one way you can choose 2 balls out of 5 identical red balls. इसलिए हमने जो क्वेश्चन लिखा था यहाँ पे देखो, we have 8 different chocolates बोला था, चॉकलेट्स डिफरेंट है तभी तो चूज करने का कोई सेंस बनेगा, वरना तो कोई भी 3 दे दो, सारे चॉकलेट सेम है तो 3 दे के बांट दो, तो एक ही तरीका है। बट इफ चॉकलेट्स आर डिफरेंट देन ओनली क्वेश्चन मेक सेंस। नेक्स्ट, हाउ मेनी वेज टू चूज 3 डिजिट्स फ्रॉम दिस 5 डिजिट्स? क्या करना है? वी वांट टू चूज 3 डिजिट्स आउट ऑफ 5। हाउ मेनी वेज आर देयर? 5 चूज 3, चूज ही तो करना है, उसके साथ क्या करना है वो नहीं बोला है, we just have to choose. Next, how many ways are there to choose ordered pair of 3 digits from these numbers? And next question देखो, 3 digit numbers can be formed. दोनों क्वेश्चन अलग है, because when you have 3 digit number automatically 0 cannot come at the hundreds place. But when we have to choose just ordered pairs, just pair चाहिए मुझे 3 चीजों का और ऑर्डर्स के साथ चाहिए, ऑर्डर्ड पेयर में 0 फर्स्ट आ सकता है, इट डजंट मैटर कि 0 कहां पे आ रहा है, बिकॉज दिस इज जस्ट देयर इज जस्ट ऑर्डर इज इंपॉर्टेंट, बट यहां पे इट हैज स्पेसिफिकली सेइंग 3 डिजिट नंबर, यहां पे 0 हंड्रेड्स प्लेस में नहीं आ सकता। तो हाउ मेनी ऑर्डर्ड पेयर्स? इट विल बी 5p3, एंड हियर ये अब ऐसे का वैसे करना पड़ेगा अपने को पुराना वाला, क्योंकि वी हैव 6 0 1 2 3 4 5 है क्या, तो 6c3 है, चलो 6c3, यहाँ पे 6p3, and यहाँ पे here we have 5 choices, here we have 5 choices, here we have 4 choices, right? So it is 20 into 4, 25 into 4, 100. 100 will be the answer. Here numbers would be higher. So I hope you understand the difference between these 3 questions. Here we just have to choose. Here we have to talk about ordered pairs, and here we have to talk about 3 digit numbers. ये दोनों question अलग है. Fine. Next is circular sitting. Just there is one concept involved, and that is all. यहाँ पे कुछ और different कुछ नहीं होगा, और इसमें कंडीशन डाले जाएंगे तो आपको उस हिसाब से अपने आंसर्स को मॉडिफाई करना पड़ेगा। Here we will have a circular table instead of linear sitting. So first question is, how many ways are there to sit 5 people around a circular table with chairs equidistant? तो मतलब circular table है एकदम uniformly, ideal circular table है. So we have 5 seats and we have 5 people, let us say, waiting outside the room, and one by one they go and they sit. How many ways are there to sit? हमने क्या किया था पहले linear sitting में 5 people 5 chairs, so it must be 5 factorial. But here the things change, because what happens, the table is circular. Table is exactly circular, so there is no linear order. Order यहाँ पे defined ही नहीं है. Chairs यहाँ पे है but सारे equidistant है. There is no difference between these chairs. The chairs are identical. So if the first person enters the room, how many options does he have? He has only one option, क्योंकि पांचों चेयर आइडेंटिकल है. The thing is, this is important to recall. जब हमने बॉल वाला एग्जांपल किया था कि how many ways you can choose 2 balls from 5 identical red balls, तो वो एक ही तरीका है क्योंकि सारे बॉल्स ही आइडेंटिकल है. इट डजंट मैटर कौन से दो लेते हो. यहाँ पे भी वैसा ही है. इफ द फर्स्ट पर्सन एंटर्स द रूम एंड ही सीज 5 चेयर्स, he does not have 5 options, he has only one option. कहीं पे भी जाके बैठ जाए, वो कहीं पे भी जाके बैठ जाए, and that is all. And it doesn't not matter कि कहाँ पे बैठ जाए, because all chairs are same. तो एक जगह पे वो जो, let us say he sits here and he now what happens now कि वो बैठ गया. When the next person comes, अब order define हो चुका है, because as soon as this person sits, first person, उसके लेफ्ट में फर्स्ट, उसके लेफ्ट में सेकंड, उसके लेफ्ट में थर्ड, उसके राइट में फर्स्ट, उसके राइट में सेकंड. सो यू सी द ऑर्डर दैट इज गेटिंग डिफाइंड एज सून एज द फर्स्ट पर्सन सिट्स. जब पहला बंदा बैठेगा ऑर्डर डिफाइन हो जाएगा. अब क्या हो गया, वंस द ऑर्डर इज डिफाइंड, so there are 4 people and 4 chairs, so there are 4 factorial number of ways. That is how you have to solve circular arrangement wala question. The number of ways n people can be seated around a circular table, it is n minus 1 factorial. Why? Because only when the first person sits does the order get defined. Before that there is no order, all chairs are identical. That is the idea. अब इसमें भी मॉडिफिकेशन हो सकते हैं, that 2 person want to sit together, 2 person want to sit opposite, या फिर there are more people than 5. Let us say यहाँ पे what happens, there are 8 people and only 5 chairs. So how do you sit? So firstly we have to choose which 5 are going to sit. 8C5, and out of, if once you choose them, once you choose these 5 people, then this will be 5 minus 1 factorial, na? If first person goes, it sits inside, then order is defined, and then the rest of them would be selected. So this would be the answer. So ऐसे आप modify कर सकते हो. We can have 2 people want to sit together, so treat them as a block. 2 people want to sit opposite, so first ensure that they are sitting opposite. We can have if the 5 में तो नहीं, लेकिन if you have, let us say 6 people, so we have if you have 6 people, then sit 2 of them want to sit opposite to each other, so they can sit here or here or here. Take it one place, rearrange others, and then just multiply, because if the chairs are numbered, then you can act according to that. If chairs are identical, then no need to consider separate cases. Fine. Next section is number of paths. These are all types of questions that can get asked, and very very standard things. एक बार समझ लो कि कैसे करना है कौन सा क्वेश्चन, और वो हो जाएगा. See, question is A is here, B is here, or what is the number of ways can a person reach point B starting from point A along the shortest path? And along the shortest path, person will, तो मतलब यहाँ से यहाँ जाना है, A से B जाना है. The person wants to go from A to B, and he can only go right or up. Left नहीं जाना है, down नहीं जाना है. Okay, he can only go right or up, and along these straight lines जाना, ऐसा नहीं बीच में से जाना. तो observe that whenever person goes right or up, ultimately कोई भी path ले ले, ultimately because these are all squares, ultimately he has to go 1 2 3 4 5 6 7 to the right and 4 to the up. ultimately he has to travel this distance, that 11 units in some order. तो पहले राइट जा सकता है, फिर अप, राइट अप, तो मतलब आर यू आर यू आर यू, फिर आर यू, देन आर आर आर. दिस इज द पाथ. ठीक है. या फिर कुछ भी कर सकता है, फिर सारे पहले राइट फिर अप, तो आर 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 आर, फिर अप 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 अप, पहले अप 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 जा सकता है, फिर राइट राइट जा सकता है, या फिर कोई भी पाथ ले सकता है वो. इट विल बी अल्टीमेटली some rearrangement of these 7 R's and 4 U's, because ultimately he has to travel that distance. The person will go 7 right and 4 up without taking left or down. So he or she will have to travel 11 unit distance, and out of those 11 unit distance, they will be traveling R 7 times and U 4 times. So is it not same as anagram? कि 7 times R है, 4 times U है, और इसी का anagram बनाना है. Question is how many anagrams are possible? How many number of paths are possible? It will be simply 11 factorial divided by 7 factorial into 4 factorial. R 7 बार आ रहा है, 4 बार U आ रहा है, and total there are 11. This will be the answer. है कि नहीं? Simple. And it will be calculation भी कर सकते हो इसका, तो 11 into 10 into 9 into 8. Because 7 factorial cancel हो जाएंगे, and divided by 4 factorial. 4 factorial क्या है? 4 into 3 into 2 into 1. तो 4 into 2 के साथ 8 कट जाएगा, 3 ones, 3 3s are 9. So 11 into 10, 11 into 10 is 110, 110 into 3. So it is 330. Simple. है कि नहीं? That is the number of paths. This is how you solve. Is same as finding out anagrams of this 7 times R, 4 times U. It is 11 factorial divided by 7 factorial or R factorial. Or alternatively, basically we have to choose in how many ways can a person who wants to travel 11 unit distance takes 7 rights. So it is right कब लेना है वो choose करना है. 11 choose 7, right? So 11 unit में से कब right लेना है वो choose करना है. तो 7 times you have to check, right? So 11 choose 7, which is same as this. So anyway, you can think about it. I think this is the last section I want to discuss before we take some PYQs, before we discuss some PYQs. So let us discuss this. Non-zero solutions to linear equation. Number of, just remember this is addition. So if you are comfortable, अभी तक किया हुआ तो ये छोड़ दो. अगर if you are not comfortable with this section, then forget about it. If you are, then you may use it somewhere if you can frame such kind of equation. तो इस बार एक सवाल आया था जिसमें this is calculation by a lot. That is why I have included it. Number of non-zero solutions to this linear equation x1 plus x2 plus up to x dot 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 xr is equal to n, where x1, x2, these are all variables which are greater than or equal to 0. Everything has coefficient 1, and number of integer solutions of this non-zero integer solutions of this equation are given by n plus r minus 1. Choose r minus 1. Just remember this. कहाँ से आया, क्यों आया? For now it doesn't matter. But use कैसे करना है? Let us see. Question देखो. How many ways are there to distribute 4 chocolates among 5 boys? We want to distribute 4 chocolates among 5 boys. Nothing has been given about chocolates or the boys. And there is no information given कि किस boy को कितनी देनी है वगैरह. So let us assume that boy 1 gets x1 chocolates, boy 2 gets x2 chocolates, and so on. तो क्या चाहिए हमें? x1 plus x2 plus x3, total हमें x plus x5 will be 4, क्योंकि टोटल 4 ही चॉकलेट्स हैं. क्या पता तुम्हें कि बॉय 1 को ही सारी चॉकलेट्स मिल गई है? सबको 0 और ग्रेटर देन 0 चॉकलेट्स मिल सकती है, और सारे चॉकलेट्स का सम मिला के हमें 4 होगा. This is how you use it. x1 plus x2 plus up to x5 is equal to 4. Number of solutions of this is what the number of ways is, which is 4 plus 5 minus 1. Choose 5 minus 1 is equal to 8c4 is equal to 70. So there are 70 ways in which we can have this. Remember, r is this. R is number of variables and n is whatever on the right hand. इस बार I think there one more question, I think example, और इस बार आया था, I don't remember, that we have, let us say 10 balls. These are same balls, 10 balls, and we want to put them in 4 boxes. Box 1, box 2, box 3, box. Boxes are different, balls are same. How many ways are there to do it? कि मतलब ऐसा कोई कंडीशन नहीं है कि हर बॉक्स में एक एक जाना ही चाहिए या फिर इतने इसमें जाने चाहिए वगैरह. We just want to put the balls because the balls are different. Let we all assume x1 balls in this, x2 balls in this, x3 balls in this, and x4 balls in this. We add all of them. We should get total 10 balls. 10 balls को distribute कर रहे हैं. So the answer to how many ways are there is number of solutions of this, which is n, which is 10 plus r minus 1. Choose r, which is again 4 minus. So it is 13c 3 equal to 13 factorial divided by 3 factorial into 10 factorial. तो जो भी आंसर है वो आंसर इसका होगा. If the question is like this, that there are 10 balls and we have to put them in these 4 boxes, but condition is at least one ball has to go in each box. एक बॉल तो जाना ही चाहिए हर बॉक्स में. अब नंबर ऑफ वेज बताओ. So what we will do, we will just simply take 4 balls, put एक एक पहले डाल दो पहले से, that condition gets fulfilled. Now we have only 6 balls and we can distribute them in whatever way we like. So it will be just x1 plus x2 plus x3 plus x4 is equal to 6. Instead of 10, it will be 6. क्योंकि हमने पहले ही 4 बॉल एक एक डाल दिया सब में, तो अब 6 ही बच गए. क्यों डाले? क्योंकि कंडीशन फुलफिल कर ली पहले से. So that number of ways will be this. कि 4 plus 6 minus 1, so 10 minus 1, 9c3. 9c3 would be the answer. अब ये समझ में आ रहा है तो अच्छी बात है. नहीं आ रहा है कोई बात नहीं, एक आध क्वेश्चन छोड़ दो तो चले. Let us do some PYQs. These are not all PYQs of past few years or anything like that. This is just some representative PYQs I have taken because this is such an important topic. That is why. If you want to see the discussion of all the 5-year PYQs from 19 to 24, 23, 19 to 23, please go to PYQ series on LevelUp IAS YouTube channel. वहाँ पे पिछले 5 साल के पिछले 5 साल के PYQ discussion we have uploaded. See the question. We have a flag which is to be designed with 4 horizontal stripes using some or all colors of red, green and yellow. तो मतलब 3 colors है हमारे पास. We have 4 stripes. 1, 2, 3 and 4 stripes, and we have 3 colors: red, green and yellow. What is the number of different ways in which this can be done so that no 2 adjacent strips have the same color? That is the condition. Fine. अब कहीं से भी start कर लो. Let us start from above, topmost stripe. How many choices for this? We have 3 choices. कोई भी 3 में से एक कलर दे दो. Now कोई भी कलर दे दिया. अब इसके लिए कितने choices बचे? Only 2. है कि नहीं? Because ये वाला कलर आ नहीं सकता यहाँ पे. That is the only condition कि बाजू बाजू में सेम कलर नहीं आना चाहिए. यहाँ पे दो ऑप्शन बच गए क्योंकि यहाँ का एक यहाँ पे नहीं आ सकता. अब यहाँ पे थर्ड के लिए ये वाला नहीं आ सकता. Third thing, again 2 options because whatever color here is given, that cannot come here. Out of 3, other 2 can come. And last one, again this color cannot come here. Options, 2 options. So total number of, we have to choose color for stripe 1 and stripe 2 and stripe 3 and stripe 4, and is multiplication. Just multiply all these things, you will get answer as 20. This is multiplication principle. हर साल कोई ना कोई आता ही है multiplication principle पे question. Just have to remember that all the choices you have to take correctly. क्योंकि अभी तो blank के flag, तो ऊपर से start करोगे तो भरते भरते आओगे. तो ऐसे मत सोचना कि इसके लिए एक ही ऑप्शन है ये और ये नहीं आ सकते. No, that is a blank space here. We have not made our choice there. So that is why 3 there, 2 there, 2 there and 2. Next, in an examination, the maximum marks for each of the 4 papers, namely PQRS, are 100, and marks scored by the student are in integers. A student can score 99% in n different ways. What is the different value of? So 99% marks चाहिए इसको out of 4 papers, 400 marks. So 99% meaning 396 marks, right? 4 मार्क्स खोने हैं, it is easier to think about it in terms of lost marks instead of marks gained. Why? Because 4 के साथ डील करना easy है 396 से. That is the reason. So we want to lose 4 marks in 4 papers. There are 2 ways you can do this. One is manual, एकदम manual calculation. जैसे कि ये मान लो PQRS 4 papers है. We have to lose 4 marks. So what we can do? 4 0 0 0 0 4 0 0 0 0 0 4. यहाँ पे 4 or 0 0 0. That is 4 ways. What else? We can have 3 plus 1. Then 3 1 0 0 or 1 3 0 0. पहले ऐसे कर 3 0 1 0, then 3 0 0 1. Then we can have 1 1 3 0 0 or 0 3 1 0 or 0 0 0 3 0 1. फर्स्ट पेपर में 3 वाले 3 केसेस, सेकंड पेपर में 3 वाले 3 केसेस, इसके 3 सो टोटल 12 केसेस ऐसे आएंगे, ऐसे 4 आएंगे और 2 वाले केसेस आएंगे. फिर दैट इज ऑल. 2 वाले केसेस कौन से आएंगे? दे विल बी जस्ट 2 2 0 0 वाले आएंगे ना. तो यू जस्ट हैव टू चूज दो पेपर जहां पे we'll have to lose 2 marks. It will be 4C2. Correct? तो 6 केसेस आएंगे वैसे. तो 12 plus 6 18 plus 4 22. Is there any other way you can lose 4 marks? Yes. So we can have 2 1 1 0 or we can have 1 1 1 1. So this is one case only and इसमें we just have to choose 2 पेपर्स जहां पे ये इस जैसा केस हो गया एकदम 3 1 0 0 जैसा कि 2 चीजें डिफरेंट 2 चीजें सेम. तो यहाँ पे अगेन 12 केसेस आएंगे. 12 12 18 प्लस 10 28 प्लस 1 29. इज देयर 29 इन द ऑप्शन? नो, कहीं पे ज्यादा हो गया क्या? नहीं 12 plus 12 24 plus 10 34 plus 1 35. 35 is there. So 35 is there in the option. That is one way. Manually just write everything and find out कि ये 4 वाले केसेस 4 0 वाले. If we have 4 0 0 0, we just have to choose a paper in which 4 marks 4 है. So that will be simply 4C1. So 4. In the 12 वाले 3 plus 1 plus 0 plus 0 ऐसे 4 marks जाने के लिए we have to choose 2 papers in which he gets 3 and 1. So we have 4C2, but 3 and 1 because we can have 3 1 and 1 3. So multiply by 2 factorial, which is 2 only. So this 12. Here again 2 2 0 0. We just have to choose in which paper he gets, which 2 paper he gets 2 marks. 2 marks. 2 lose. He loses 2 marks. It will be just 4 choice 2. Choose 2 papers. And finally, this case 2 1 1 0. It is same as 3 1 0 0 because 2 things different, 2 things same. It will be again 12 cases. And lastly 4 1 1 1 1. That is only one single case. Another way to think about it is I think you can have paper P, Q, R and S. Let he loses x1 marks here, x2 marks here, x3 marks here and x4 marks here. So total he must lose 4 marks. This is how you can have. So number of solutions of this would be 4 plus 4 minus 1. Choose 4 minus 1, which is 8 minus 1, 7, C, 3, which is 7 factorial. 7 into 6 into 5 into 4 into 5 into 4 factorial divided by 3 factorial, 4 factorial. 4 factorial get cut, 3 factorial 6 get cut, 7 into 5 you will get 30. That is again another way to do this. Either you do it manually or you do it this. अगर ये आपको समझ चमक जाता है, so it is much easier and much quicker. वहां पे थोड़ी सी एफर्ट डालना पड़ेगा. That is the only difference. ठीक है. यहाँ पे he loses x1 marks in paper P, x2 in paper Q, x3 in paper R, x4 in paper S. ये क्यों यूज किया? Because each mark is same but papers are different. वहां पे भी क्या था? Balls are same but boxes are different. तो उस केस में ये वाला यूज कर सकते हैं. नंबर ऑफ वेज आपको पता है. Next, how many distinct 8-digit numbers can be formed by rearranging the digits of the number 1 1 2 2 3 3 4 4 such that odd digits occupy odd position and even digits occupy even position. तो क्या है 8 digits है 1 2 3 4 5 6 7 8 and we have 1 1 1 1 2 2 3 3 4 4. So odd digits odd position, तो ये odd position है first position 1 1 then we have 3 3 and यहाँ पे 2 2 4 and इनको rearrange कर सकते हैं अपने आप, मतलब 1 1 3 3 can rearrange themselves odd position odd number and 2 2 4 4 can rearrange among themselves, but 2 यहाँ पे नहीं जाएगा 1 यहाँ पे नहीं जाएगा, मतलब एक दूसरे का क्रॉस नहीं कर सकते. So we can think of them in terms of two different numbers. So what we'll do, we will fix these numbers. तो जो even है ये इनको fix कर देते हैं. Let us just fix them. इनको हिलाएंगे नहीं. Let us fix 2 2 4 4 here and first let us only rearrange. मतलब यहाँ पे ये for every choice of digits of even digits at even positions ये कितने हैं ये ढूंढने की कोशिश कर रहे हैं. तो अगर इनको फिक्स किया जाए and only we'll rearrange 1 1 3 3, how many rearrangements of 1 1 3 3 are possible? It is similar to anagrams 1 1 3 3, so 4 factorial by 2 factorial 2 factorial है कि नहीं. 1 1 3 3 a c c जैसा है, मतलब दो चीजें दो बार आ रही है, तो नंबर ऑफ rearrangement is this, it is nothing but 6 4 factorial by 2 factorial 2 factorial 2 factorial 2 factorial 4, मतलब 3 into 2 6. So 6 arrangements of this and that is for every choice of even positions. So even position में कितने हैं 2 2 4 4, तो उतने की उसके कितने rearrangements हो सकते हैं, that is also 6 2 2 4 4, इसके तरह ही होगा वो. So we have to make those arrangements and for every one of that arrangement we have 6 of this. So for 6 of this we have 6 into 6 of. So answer is 6 into 6 is 30. What we are doing, for every choice of numbers at even positions we have 6 arrangements of odd positions. और वो खुद 6 है ना, एक के लिए 6 है तो 6 के लिए कितना 36 6 6 6 6 6 बस. Next, how many 3-digit natural numbers without repetition of digits are there such that each digit is odd and the number is divisible by 5? अब each digit is odd meaning we can have 1 3 5 7 9 as the only possible digits because these are the only odd digits we have and we want to have 3-digit natural number. We want to have 3-digit natural number divisible by 5. तो 5 के लिए divisible होने के लिए यहाँ पे बस 5 ही होना पड़ेगा, no other choice. तो यहाँ पे 5 फिक्स हो गया and क्या दिया है without repetition that is mentioned. तो चार बचे ना, 5 तो यहाँ पे यूज हो गया तो 4 बच गए, तो यहाँ पे 4 choices and यहाँ पे 3 choices. That is all. यहाँ पे तो 5 ही आएगा, no choice. Answer is well as simple as that. This CSAT 2022, not an old question. Just 4 into 3 करना, इतना ही था. Odd digits पहचानने, odd digits, each digit is odd, तो इनमें से ही सारे आएंगे plus divisible by 5, तो end में 5 ही आएगा. We just have to choose 2 digits. Choice here is only for 2. यहाँ पे 4 choices because 5 यूज हो गए and यहाँ पे 3 choices because यहाँ पे भी एक यूज हो गया. अब 4 into 3, 12 is the answer. Let us see next question. The letters A, B, C, D, E are arranged in such a way that there are exactly 2 letters between A and E. How many such arrangements are possible? तो 5 चीजें हैं and A and E के बीच में exactly 2 है. So we can have A 1 1 E here, or we can have E A here, or we can have A E E blank blank. These are the 4 options we have and rest are BCD. So here BCD can be arranged in 3 factorial, which is 6 ways. 1 2 3 3 positions, 3 letters, 3 different letters. So we have 3 factorial rearrangement, which is 6. यहाँ पे भी 6, यहाँ पे 6, यहाँ पे 6, and we can have this or this or this or this, मतलब cases ही बना लिए. So we can have this or this or this or this. So we have total 24 cases. Number of ways is 24. Fine. हाँ, see, there are 9 cups placed on table, arranged in equal number of rows and columns. So मतलब जैसे 3 by 3 में अरेंज किया है. We have 6 coffee and 3 cups of tea. Question: in how many ways can they be arranged so that each row should contain at least 1 cup of coffee? अब ये जब भी at least वाला question आता है, that is for future. That is why I have chosen this question. कि at least वाला question में क्या करना? We have to choose. We have to do whenever the question based on this kind of language that every row should contain at least 1 cup of coffee. इसको कैसे solve करना है? All we have to do at least 1 cup of coffee मतलब क्या? एक भी चलेगा, दो भी चलेगा, तीन भी चलेगा हर रो में, ठीक है. बट क्या नहीं चलेगा? जीरो नहीं चलेगा बस. तो out of the total possible cases, if we remove all those cases where a row does not have any cup of coffee, जहां पे 0 cup of coffee है रो में, if you remove those cases, we will get at least वाले आंसर. So total में से जब ये नहीं हो रहा है, वो वाले केसेस हम रिमूव करते हैं, then we get the answer. So out of the total possible cases, we just have to remove cases where there is no cup of coffee in the row. What is the total cases? There are 9 positions here and there are 6 coffee and 3 tea. So we just have to choose out of 9. टी कहां पे जाएगा, राइट? या फिर कॉफी चूज कर लो, सेम एज कॉफी कहां पे जाएगी, वो 6 पोजीशन चूज कर लो, बचे हुए जगह पे टी जाएगा. या फिर टी कहां पे जाएगा, 3 वो चूज कर लो, बाकी जगह पे कॉफी चला जाएगा. And if you see this quantity, 3 factorial by 6 factorial into 3 factorial, it will be 9 into 8 into 7 divided by 6. No? So it is 9 8 72. 72 by 6, which is 12. 12 into 7, which is 84. So number of ways we can put these things, total number of ways without any condition is 84. अब at least 1 cup of coffee के लिए क्या चाहिए हमें? इसमें से बस 0 cup of coffee वाला केसेस रिमूव कर देंगे. मतलब नो कप ऑफ कॉफी इन द रो. वो कब होगा? जब यहाँ पे टी ऐसे आएंगे, then will not have any coffee in this row. That is case number 1. Second, ये तीनों टी बीच वाले रो में आ सकते हैं. थर्ड, तीनों टी नीचे वाले रो में आ सकते हैं. That is the only thing. These are the only 3 cases when there will be no cup of coffee in a row. है कि नहीं? Because अगर तीनों चाय 3 है, कॉफी 6 है, अगर इस रो में कॉफी नहीं आना चाहिए, if you want to have no coffee cup in first row, all the 3 tea cups must come in that row. That is only one case. Second case, all 3 tea cups in second row, all 3 tea cups in third row. Only 3 cases out of 84. If you subtract these 3 cases, answer is 81 cases will be such that we'll have at least 1 cup of coffee in every row. I hope you understand. Next, again, simple multiplication principle question. One non-zero digit, one vowel, and one consonant from English alphabet in capital are to be used in forming password. Non-zero digit. How many non-zero digits are there? 1 to 9. Vowels, 5 vowels. Consonants. I hope you know what consonants are. All those letters which are not vowels are called consonants. So these are 9 digits. Such that each password has to start with a vowel, end with a consonant. So यहाँ पे number and यहाँ पे consonant. How many such password can be generated? We have to choose 3 things. We have to choose vowel and number and consonant. And is multiplication. And these 3 things are independent choices. These choices have nothing to do with previous choice. So vowels के लिए 5 choices, numbers के लिए 9 choices, consonants के लिए 21 choices. Total 945 choices. Answer is as simple as that. Directly multiply करना है तीनों numbers को and that is your answer. Next, what is the number of numbers of the form 0.xy where x and y are distinct non-zero digit? Distinct है वो, same नहीं है, मतलब repetition नहीं है. So we have 0.xy. We have non-zero digits, matlab how many digits are there non-zero? 9. 1 to 9. So for x we can have 9 choices, and because they are distinct, for y we can have 8 choices. How many total choices? 72. As simple as that. Again, this is CSE 2022. पुराना question नहीं है. These are not old question. What is the number of numbers? It is 72. Next, A, B, C are three places such that there are three different roads between A to B. So we have A, B, C. We have three roads from here to here. Four from B to C, and from A to C, 3. Right? Yes. So how many roads can we have? Can one person travel from A to C? From A to C we want to go. So we have these three choices, or we can have A to B and B to C. We have to choose path from A to B. So there are 3 ways to do that, and we have to choose path from B to C. So there are 4 ways to do that. So 4 into 3, 12 ways to do that. 12 plus 3, 15 total. Easy. Next, using 22333 as digits, how many distinct numbers? Question is how many distinct numbers greater than 30,000 can be formed? We want to form numbers greater than 30,000. So मतलब 5 digits number है. If you want a number greater than 30,000, यहाँ पे 3 ही आना चाहिए, 2 तो आ नहीं सकता, है ना? तो यहाँ पे 3 फिक्स हो गया, राइट? अब कोई चॉइस ही बचा नहीं उधर. We just have 4 चिन्ह. वो कहीं पे भी कुछ भी आ जाए, that number will always be greater than 30,000. So we have 2, 2, 3, 3 to rearrange in these 4 things. How many rearrangements? 4 factorial by 2 factorial into 2 factorial, just like anagrams, which is 6. So there are 6 numbers. Easy. Next, there are 6 persons in a row. Another person has to shake hands with 3 of them, so that he should not shake hands with 2 consecutive persons. In how many distinct possible combination can the handshake takes place? So handshake करना है. There are 6 persons arranged in a row. तो यहाँ पे let us call them A, B, C, D, E, F, and person has to shake hands with 3 of them, such that 2 consecutive लोगों के बीच में handshake नहीं होना चाहिए. So we can have A, C, E, this, right? We can have A, C, F, correct? Then we can have A, D, F, है ना? That is all with A. E, F नहीं हो सकता. So we can have A with A से यही हो सकते हैं. Then we can have with B. We can have B, D, F. Then we can have what else we can have? Can we have any other option? I think that is all. So 4 है. 4. So just manual counting. आधे questions, मतलब half the questions out of total will be from manual counting, just like that, and half the questions will be from the standard thing. How many 5-letter words can be made with the word Delhi, so that each letter has to start with D and end with I? So start with D, end with I. So क्या बचा? ELH बचा. So we have only 3 factorial, 3 things, 3 positions. We have 3 factorial, which is 6. Correct? 6 different rearrangements. Okay, that is all from my side. I hope this session was helpful for you, and if you have any doubts, do put in comment section or reach out to us at LevelUp IAS website. And if you want a full booklet, it is available on my Telegram channel, CSE/IFoS with Abhishek. You can go there and download. What else? Yes, if you want to see solutions of all the PYQs of last 5 years, because these were just the representative ones, please go to YouTube channel of LevelUp IAS and see the PYQ series there. And that is all. Study well, do well, practice a lot. This is an important chapter जहाँ से again from where 9-10 questions might come this year again. So if you can solve half of them, then also it will be big boost to ensure your selection in the CSAT paper. So or ensure that you don't get eliminated because of CSAT paper rather. So all the best and thank you.